Thank you. Well, thank you so much for that introduction, and thank you to the conference organizers for inviting me to be here. I'm really excited to get to talk to you guys, and I also want to say thank you to this community, because as I will describe in my talk this morning, my team relies on a lot of the tools that have been implemented and maintained by this community to do our work. So thank you for the work that you do. It makes our work possible. This morning, I'm going to tell you a little bit about my organization and what we do. I'll go over very briefly the two primary analytical methods that we rely on, and then basically I'll go through a couple of quick examples to highlight the ways that we use some of these tools. My idea this morning is that these are just examples, not tutorials, so I will sort of gloss over some of the implementation details, but of course during Q&A or offline afterwards, I'm happy to dig into all of those details. And then I'll wrap things up. Well, as was mentioned, I'm the executive director of the Human Rights Data Analysis Group, or HRDAG. We're a nonprofit organization based here in San Francisco. And what we do is we provide the analytical underpinnings for human rights advocacy work. So in a sense, we're the scientists behind the scenes for other human rights advocacy organizations. Collectively, our team has been doing this work for a little over 25 years, and we've had the great fortune to work to partner with a wide variety of organizations. Everything from large international organizations like Human Rights Watch or Amnesty International, to various United Nations missions, to truth commissions, to local grassroots non-governmental organizations. Now, where our analysis ultimately ends up varies from project to project and country to country that we work in. Sometimes we produce a memo or a white paper or a technical appendix to a Truth Commission report, but I think one of the most tangible and visible ways that our analyses can contribute to justice is when we're invited to testify in court cases. This happened in 2002 with my colleague and HRDAG co-founder, Dr. Patrick Ball, when he testified against Slobodan Milosevic at the International Criminal Tribunal for the former Yugoslavia. What he's presenting here are patterns of refugee flow as people fled across the border into Albania, and also patterns of known killings that occurred during that conflict. He also testified in 2013, this time in Guatemala, against General Efrain Rios Montt, who was the de facto leader of Guatemala in the 1980s and was charged with acts of genocide. The analyses that we presented in that case were a comparison of the relative risk of death for members of the indigenous population as compared to the relative risk of death for members of the non-indigenous population. And the wide disparity in those differences in relative risks, the lawyers argued, were consistent with patterns you would expect to see if acts of genocide were occurring. Now, Rios Montt was found guilty, but that verdict only stood for 10 days. The Constitutional Court overturned the verdict on a legal technicality. There are efforts right now to restart that trial, but there is a long and winding legal road ahead of those efforts. Most recently last year, Patrick testified again against Hissène Habré, the former leader of Chad in the 1980s. This time, Patrick presented crude mortality rates for prisoners in prisons run by secret police under the command of Hissène Habré. Now, this particular story has a slightly better coda. Just a few months ago, in May of this year, Hissène Habré was found guilty and sentenced to life in prison. So those are some of the biggest, most visible outcomes of some of our work. But what's the actual analytical work that we're presenting in those cases? Well, we rely primarily on two classes of methods, one of which is record linkage or database deduplication. And just to get a sense, who is already familiar with record linkage problems? Okay. So this crops up in a wide variety of applications. Essentially, it involves needing to identify when multiple records refer to the same individual or event or entity. And I'll talk about how that crops up in our specific work. But this is an incomplete list of the references that have influenced our thinking and our work in this particular area. And perhaps most applicable for this audience, of course, is that we rely very heavily on SciPy, NumPy, and sklearn to do this particular piece of our work. The other main analytical method that we use is a class of statistical tools called multiple systems estimation, or sometimes where it was developed in ecology, it's referred to as capture-recapture. This is a broad class of tools that's been developed in everything from ecology to demography to statistics to public health research and now to human rights work. Again, this is an incomplete list of the references that have influenced our thinking on this work. Primarily, we implement our MSc work in a variety of R packages. Given the title of this conference, I'm going to focus this morning primarily on the work we do in Python, but if folks want to talk about R as well, I'm happy to get into that during Q&A or offline afterwards. So to get into this morning's particular example, this project started, as so many of our projects do, when a partner approached us with some data and a question. What happened was in 2012, the United Nations Office of the High Commissioner for Human Rights came to us, and at the time they had access to 4 different lists of named victims who had been killed in the ongoing conflict in Syria. And they came to us and they said, this is a little bit different from the kinds of situations we usually work in. We don't usually have multiple sources, and we're not really sure how to make heads or tails of this information. And so we partnered with them between 2012 and 2014, and we published a number of joint reports. This is the last official one from August 2014, but I should emphasize that this headline is missing 2 very important modifiers, because what those reports in fact described was the number of documented, identifiable victims who'd been killed in Syria. And if you think about the nature of an ongoing conflict like the one that's happening in Syria right now, it rapidly becomes clear that documented, identifiable victims must be a subset of the total number of victims. Because of course, there are individuals who have been killed whose names we do not yet know, whose stories have not yet been told. And it's our job as statisticians, as data scientists, to use the tools available to us to estimate what we don't know. But that's actually a whole nother talk. We have to start with what we do know and with what has been observed and recorded. And so that's the work that I'm going to talk about this morning. In this particular case, we start with 4 sources. There's an asterisk there because if you're familiar with the UN reports, the number of sources varied across the reports, and actually the specific sources that we had access to varied over the course of that collaboration. But the work that I'm going to talk about specifically this morning is involving information from 4 sources: the Center for Statistics and Research Syria, the Damascus Center for Human Rights Studies, the Syrian Network for Human Rights, and the Violations Documentation Center. Now, between those 4 sources, there are over 400,000 records. But I really need to emphasize and make absolutely clear that that in no way implies that that's the number of victims in this conflict. That's the number of named victims across all 4 of those sources. And there's a lot of duplication in those records because some victims may be reported to the same source multiple times, perhaps by different members of their community, or the same victim may be reported to multiple sources. Perhaps each of the sources have access to the same original information, be that a religious leader or a morgue record or hospital records. So this is the aggregated total number of named victims across all 4 of these sources. And this is why we start with a record linkage problem, because we need to identify those multiple records that refer to the same individual. And for this morning, the records that I'm talking about cover the period from the beginning of the conflict through the end of last year. So when I talk about sources and records, what do I mean? What does the data actually look like? In this case, it literally is a list of named victims. This is a screenshot from the Violations Documentation Center. This is a public-facing website that they maintain, so anyone has access to this information. That's part of their advocacy efforts. They believe it's important to make this information available to draw attention to the conflict and tell the story of the victims. And all 4 of the groups record very similar information: the name of the victim, the date and location where they were killed, and then occasionally we get other demographic information. In most cases, we know their sex. Rarely do we know their age, although the groups do try and record that information, and a few other bits of demographic information. So like I said, this becomes a record linkage problem, because the first thing we need to do is to identify the total number of uniquely identified victims who are described by these 4 sources. So this diagram describes the way our team thinks of this record linkage problem. And if you're familiar with this class of methods, specifically what we implement is supervised record linkage. So the outside of the circle, everything that talks about human labeling and starts with a TS, that's where we send records out to humans and ask them to review it. And there's a lot of iteration through those loops. I'm going to primarily focus this morning on the middle of the diagram. And specifically, I'm going to focus mostly on compare, classify, and cluster. But just to very briefly explain sort of the process that the data goes through in this pipeline, of course, we import the post-processed analysis-ready information from each of our sources. And then the first thing we have to do is a step called blocking. And that's because the first way that we want to think about these records, if our goal is to identify multiple records that refer to the same individual, we need to compare pairs of records to each other. So we need to start to think of our records like this. And just out of curiosity, do I have any Arabic speakers in the audience? It looks a little funny, right? Because when I mix Arabic and English, one of the languages has to end up backwards. And so the Arabic names here are backwards, so my apologies. But this is how we start to think about the records. But if we start with 400,000 records and we draw every possible pairwise comparison, it becomes computationally intractable very fast. So the first thing we need to do is to figure out a set of rules to reduce the number of pairwise comparisons we need to make. But it's complicated because any pairwise comparison we choose not to make is a potential match that we're going to miss, that we'll never have a chance to go back and get. So we have these competing interests where we want to reduce the number of comparisons we have to make down to something that is feasible, but we also want to make sure that we're comparing all the records that we should. So we want to make some rules so that we reduce these records down to groups of records that are already similar in some way. Now, it turns out that this problem is actually so complicated that my colleague Patrick Ball wrote a 5-part blog series describing how we ultimately solved this problem. It's available on our website. It's in a corner of the website we're developing called the Tech Corner, where we're starting to include more of these technical details of some of our work. And it's all written in Jupyter notebooks. It includes code snippets, so you can work through all of those details if you're curious about them. But that's the blocking step. So now I'm going to focus primarily on the next 3. So if we think that we've finished that first step, we miraculously somehow have a number of comparisons that's manageable. Now we need to numerically summarize how similar or dissimilar each of those pairs of records are. So we need to create some feature vectors that describe, for example, the number of days apart between the recorded dates of death, whether the location of those deaths is geographically nearby, and then most of the action, of course, is in the names. So we want to do some typical things. We want to look at edit distance between the names. We use Levenstein and Jaro implementations in Python. We want to look at the phonetic similarities of the names. We use a metaphone implementation in Python. We want to look at the name tokens. We want to see how similar in a variety of ways all of these records are. So we end up, at the end of the day, with these feature vectors for each pair that we consider. And that summarizes how similar or different each pair is to each other. And now we need to make a decision. Are those pairs, in fact, the same individual person? And to do that, we need a classification model. Now, fortunately for us, sklearn has basically any classification model you might ever want to consider, and it also has baked in all of these really useful metrics for evaluating those classification models. And I also have to say that the documentation for sklearn is so useful for carrying out that evaluation, for making decisions about how your classification models are performing. And so here we're just trying out a few different classification models, trying to make some decisions. And what we're feeding into these models are those feature vectors, the numerical summaries of how similar or dissimilar each pair are, and the labeled data or the training data that we've generated by sending pairs of records out to humans and asking them to label them, yes, they refer to the same individual, no, they don't refer to the same individual. And in the literature, this role is actually referred to as an oracle, which I think is possibly the best job title ever. So we have a couple of oracles go out, label a subset of the data, and then that's what we're feeding into these classification models. So in this case, we're trying a random forest, a decision tree, and logistic regression, and oof, the random forest is killing us. But what we're feeding that model is the X are those comparison vectors or feature vectors, and the Y are the labels from the oracle reviews. And then vectors is just the pandas data frame that data lives in. And then what we're going to get out of each of these models is technically a score. I think of it as a probability. Depending upon what model you're fitting, it may or may not truly be a probability. But essentially, it is a way to make a decision about whether those two records refer to the same individual or not. So you use the metrics that are baked into sklearn, you evaluate your different model possibilities, and ultimately, you make some kind of a decision. In our case, we actually ended up going with XGBoost. But that's how you classify records as referring to the same individual or not. But now, we only have considered pairwise comparisons, and now we need to move to clustering. Because if I decide, based on the score that I get out of a classification model, that record A and record B are the same person, and record B and record C are the same person, is it the right thing to do to transitively close those relationships and say records A, B, and C are a cluster of 3 that all describe the same person? Well, that's where we need to start. And so again, this is where we turn to network X and then a class of functions that are in SciPy cluster hierarchy. So the first thing that we're doing here is we're just reading in those classified pairs. And I included this little code snippet mostly because I wanted to highlight we've read in over 44 million pairs. So we're not quite to big data yet. We can pass that around in memory, but it's a big enough file that we need to be really thoughtful about any manipulations we're going to do to it, any sort of passing back and forth that we're going to do. And these 44 million classified pairs are what come out of that first blocking step. If we didn't go through that complication of blocking, we would have billions with a B pairs. So just getting down to something that we can handle in memory requires that first step. But fortunately for us, we do get down to something that is very manageable. So we read in all of these pairs that now have scores associated with them from our classification model. And now we're going to group them into clusters. So we're going to use network X to draw a graph. We're going to set a somewhat arbitrary threshold because it's something that we're going to experiment with moving around on. And we're going to use that threshold to say Any pair that has a score above that threshold, we're going to declare a match. We're going to say that pair of records refers to the same individual. And we're going to use those positive pairs to add edges to our graph. And then from there, we can generate these connected components, which essentially are our clusters. They do that transitive closure. They say if these pairs match and these other pairs match, bring them together into a cluster, which is a pretty reasonable place to start. But if we look at those connected components and we look at the size of the clusters they generate, largely they generate fairly reasonable clusters of small sizes. But then we have a few out there at the tail that are very big. And in fact, in this particular case, we have one cluster that contains over 12,000 records. And I don't believe that's true. I don't believe one person was reported to these sources 12,000 times. And that's the weakness of transitive closure, is that sometimes you have a few records that appear to be similar to a lot of other records. And you need to go break those back up. And the best way that we've found to do that is using hierarchical agglomerative clustering, which again, thank goodness, baked into sklearn, or baked into SciPy, my apologies. But it turns out that it's very slow to run, and that it's very complicated to get to run over all of these different connected components. And so, again, this is one of those complicated problems that Patrick ended up writing up for us in our tech corner. And I really enjoy in this particular write-up, he describes how he enthusiastically set about solving the wrong problem for a few days. I imagine all of us can sympathize with that. And so he highlights sort of going through the process of recognizing what the right problem was, which in this particular case was that there were multiple different ways to implement the hierarchical agglomerative clustering algorithm. And he needed two different ways, because one way was faster for smaller clusters, and one way was faster for bigger clusters. And so he needed a mixed solution. And so this blog post, again, sort of runs through all of those technical details. It's another Jupyter notebook, code snippets, the usual kinds of things. One other thing that I just want to highlight, again, from that class of functions in SciPy clustering hierarchy, is a function called dendrograms. And we found this really useful because as we were going through this process and as we were evaluating the results that we were getting, we were noticing that when we send pairs to the oracles and we ask them yes or no, do these refer to the same individual, they had a tendency to overmatch, which isn't all that surprising because if all you have to look at are two records in isolation, and the records are a little bit different, but kind of similar, you might be inclined to say, yes, those are probably a match. But if instead you see those two pairs as part of a broader cluster like this, that all have some similarities and some differences, then it gets easier to identify, oh, those two that looked similar, in fact, belong to separate clusters that describe different, distinct individual victims. And so what we started to do in the iterative process that we work through, where we fit our classification models and we run our algorithms and we cluster records together, but then we also send things back to the Oracle for review, and we develop more training data and iterate until we think we've arrived at the right answer, is that sending our Oracle records that looked like this, and in fact including the dendrogram visualization, really helped them to identify how many unique individuals are in fact described by this cluster of records. And then they could advise us on where that threshold for scores should be set. Where should we set a cut point to actually break apart these clusters in a way that makes sense? So we really rely on a variety of the tools in sklearn and in SciPy for a number of steps in this record linkage work. So that brings us to the end of clustering. That's the bulk of this record linkage work. There's a little bit of merging and post-processing, and then of course we iterate through this pipeline a lot. But the end of the record linkage piece of the work gets us to the number of uniquely identified victims who've been killed in Syria. And our substantive question is, how many people have been killed in Syria? Which is not the same question. And in fact, I've slightly mistitled my talk this morning because there's this whole other step that we have to take using multiple systems estimation to build from what we know and can observe to estimate what we don't know to actually be able to answer this question. But that's a whole nother talk. So I want to wrap up this morning with a quote from Patrick that I think really describes the motivation behind the work that we do. Because we have a tendency to really get down into the weeds of the technical aspects of the work and the scientific methods. And we are a team of scientists. We find all of those components of our work very interesting. But the reason we dive so deeply into those technical details is because at HRDAG, we believe we are morally obligated to do the best work that's technically possible so that the victim's story is heard and believed. To do otherwise disrespects the victim's suffering. So I want to say thank you again to this community for helping us to do the best work that's technically possible. Thank you. I think we have plenty of time for questions.
Where are the blogs, the technical blogs you talked about on that website?
Yes. Yeah.
Oh, great talk.
Thank you.
I guess my question is, if I'm the defense attorney, for example, and the prosecution is presenting this kind of evidence, if I'm defending, can't I just poke holes in sort of the entire methodology and say that, the data is sampled wrong, or it doesn't, you know what I mean? It seems like when you absorb more complexity in the analysis, you've created little entry points for other kinds of arguments. Does that happen, or?
Yes, that's definitely true. You could certainly try. And those are lessons that we're learning over the course of testifying in these cases. In 2002, unfortunately, a version of that basically happened, where it wasn't so much that holes were poked in our analyses, it was that the lawyers and the judges felt they couldn't evaluate the strength of the analyses, and so they just chose to disregard them. And so we've been working on, I want to say not so much, we always want to present the most rigorous analyses that we can, and fortunately with these two methods, we have sort of the full strength of the scientific community kind of backing up a lot of the choices that we're making. But what we have been really working on is how can we present such complex analyses in a way that the courtroom gets it and feels that it's useful. And I can only say that in the Rios-Montt trial, we felt like we had succeeded because the judge specifically referenced our work in her findings and said that it confirmed and amplified the witness accounts from individuals. But it definitely is an ongoing battle that we're working on, is how to present this work more clearly and how to develop more relationships within the legal system to develop sets of rules and standards for evaluating this kind of evidence in court cases. Yeah.
What jurisdictions do these typically have? I know some of them are under ICC, but is it, a variety of jurisdictional concerns, and how do different courts consider this kind of evidence differently? Should I say the second one that's completely unrelated now, or should I wait for a second?
I think wait for a second, because that's a great question, and it is a variety of jurisdictions. So in the Rios-Montt case, that was a local Guatemalan courtroom, and so that they had their own sort of jurisdictional and evidentiary rules. And then, right, with the International Criminal Tribunal for the former Yugoslavia, it was before the ICC, but it also had its own sort of special tribunal sets. So yes, each of these have their own different jurisdiction and evidentiary rules that we have to work with prosecutors to sort of figure out and understand.
How they evaluate, sort of statistical data techniques?
Not many of them are formalized specifically about statistical data techniques. The ICC is working on that, and we're trying to advise them a little bit through not we HRDAG, but we, the Technical Advisory Board, are trying to help them sort of through that process. But most of the other international jurisdictions that I'm aware of have not formalized statistical evidence. In the Guatemala case, they did formalize rules about documents, but not necessarily specifically statistical analysis.
Okay, so unrelated.
Sure.
This is purely technical. I don't know anything about Arabic orthography, but I wonder if lemmatization and metaphone, are there different libraries or different dictionaries that are used for various languages, and what's the sort of state of technology about linguistic understanding of applying it to different languages?
Yeah, yes and no. There are some different dictionaries depending on sort of which of those approaches you're taking. And in fact, in one of the blog posts we have a link to, there's kind of a warning that metaphone may or may not work appropriately on Arabic, and so we're actually trying to figure that out. But what we found empirically is that even if the metaphone function is not necessarily reflecting the true phonetic sound of the Arabic, it seems to be grouping the records in ways that are useful. So we've sort of treated that more like an implementation problem and said, well, even if substantively it doesn't make sense, it seems to be solving this problem. But that's definitely an area of ongoing study.
Great talk, very inspiring. The question I have is about the granularity. You mentioned like, oh, our team needs to check this and track with the oracles. Is it on the individual basis? Do you sample that very large data set? I mean, how are you dealing with this problem?
Yeah, how to generate training data is a big question. And we do, to start, to just seed a project, we do just sample and give the oracle sort of a random, not quite simple random, but a fairly random assortment of records to look at first. And then once we've been able to kind of bootstrap the process, what we send the oracle after that, oh, my computer's telling me that I've been staring at it for too long. My apologies. Then after that, what we do is once we have even a bad classification model, is we'll send the oracle what are called least informative pairs. And those are the ones that have a score right near where you think the threshold should be. So meaning that the model thinks it's a coin flip, the model isn't sure which way to go. And then those are the pairs that we send to the oracle so that we can keep moving pairs out of that middle. Because what we really want is the classification model to say, I know it's yes or no. They are a mother and son team in Ohio that have an inexhaustible energy for spreadsheets. They're amazing.
Has the use of social media made it easier to collect records?
Yes and no. Because there's a tremendous selection bias with social media, right? Because there's who has access to it, and especially in the case of Syria, who is savvy enough to get around sort of the internet outages and the censorship that's happening. So on the one hand, especially in Syria, a tremendous amount of our information at least partially does come from social media. So in that way, it has improved the information that we have access to. But the groups that we work with, and I think rightfully so, do not consider social media alone to be sufficient. And so they each have their own process for what I think of as like a push and a pull. So if information appears on social media, then they'll go use their local networks to investigate it using more conventional sources. And if they originally get information through more conventional sources, they may consider it confirmed if it appears on social media. So it has increased the the ubiquity and the availability of data, but it has added complexity to the data processing.
Great talk. This is a technical question. I understand you have record linkages. Did you try to use any RDFs or anything similar to that, the resource description framework that the World Wide Web uses?
Not that I know of specifically that match what the web uses. We have considered, I mean, that would come in at the feature vector state, right? Is that, am I thinking about that?
Mm-hmm. And that would basically help consolidate it.
Mm-hmm. No, I can't say that we've taken that particular approach, but I'd love to hear more about it.
Sure.
So a lot of what you presented seems to be kind of like analysis after the fact, but to what extent have you all been working with the groups that actually collect the data to be a little more proactive? Like, is that something you're also involved in?
Yeah, yes and no. You know, we absolutely try and provide some kind of value add to the groups that are doing the data collection because we want them to feel engaged. We want it to feel like a true partnership. But on the other hand, I also try to be very pragmatic about the fact that my analysis goals are not necessarily going to always match up with their advocacy goals. So just because having them record information in a certain way would make my life easier doesn't necessarily mean it serves their purposes. So I do try and feed back to them some things that I think will help them, but I try to keep to myself the things that would just make my data processing life easier. One more?
Excellent talk. Thank you very much. So you mentioned that sometimes the information, the analysis can't be consumed just because it's too complicated. And I wonder if that's something that you guys have addressed in a parallel path, like an advocacy path with government, if government institutions could embrace some of the techniques that you're doing, then that task probably might be different.
Yeah, that would be amazing. I mean, to a certain extent, you know, we certainly do consider all of our projects to be the long game. And so we do work very hard to develop those relationships where we are going to have advocates for the methods. I can't think of any specific examples where I can think of like a government entity that would have the capacity to sort of take on these particular methods. I think that would be a great end goal. But definitely, like one of the examples that comes to mind is we've been working in Colombia for decades at this point, and we've just now kind of turned the corner on our relationship with the government where they no longer think our findings are threatening, they think they're useful. And so they sort of understood them at a depth to sort of be advocates of them. So we do try and leverage those long-term relationships.
So I'd like if you could join me in a round of applause for an amazing keynote from Dr. Megan Price, Human Rights Data Analysis Group.